Good morning, this is Ms. Billerbeck, and we are going to talk about 9.7, solving systems of linear and quadratic equations. So a linear quadratic system of equations includes a linear equation, which is just the equation of this line, and a quadratic equation, which is an equation of a parabola. So we see from this graph that if the parabola hits the line in two places, it has two solutions. If the graph of the parabola only hits the line in one place, called a tangent, by the way, that's one solution. And then if the parabola never touches the line, it has no solution. So let's look at how many solutions does this system have. And a system just means there's more than one equation. So as soon as you have two or more equations, you have a system. All right, so let's take a look at y equals x. So when we look at y equals x, when y is 0, x is 0. When y is -1, x is -1. When y is 1, x is 1. And when x is 6, y is 6. So we see we have an equation that looks like this. And we can draw the line like this. So that is the line y equals x. And it has no, or the y-intercept 0 and the slope is 1. So rise 1, run 1, rise 1, run 1. So we could have just done it rise versus run after we found the y-intercept as well. All right, so now let's look at this. When x is 0, y is 0. So we have the same point there. So we'll have that right here. And then when x is 1, 1 squared is 1, so we have another solution there. When x is -1, -1 times -1 is 1, so we have a solution there. When x is 2, 2 squared is 4. And when x is -2, -2 squared is also 4. So we see, and then at 3, of course, we have 3 squared is 9. And then we have an axis of symmetry right here. So we can just count 1, 2, 3, 1, 2, 3. So we have a parabola coming down like this. And we see that we have the two solutions right there that we found right in the beginning. So we have a solution here at 0, 0, and a solution here at 1, 1. So how many solutions do we have? 2 solutions. All right, so let's go on and we're going to look at this and look at how many solutions does this have. When we do this, we probably want to set it up y equals x squared plus 1 and y equals x plus 3. Now we know that y equals x squared is the parent graph, and we're just rising up 1. So if we rise up to this y-intercept of 1, and then we graph the parent graph at when x is 1, 1 squared is 1, 1 plus 1 is 2. So we're here. Then this is the axis of symmetry is the y-axis. So we have the point here. Now, when x is 2, x squared is 4, 4 plus 1 is 5. So we're right here at 5, 1, 2, 1, 2. When x is 3, 3 squared is 9, 9 plus 1 is 10. So we go up to 10 right here. 1, 2, 3, 1, 2, 3. So we have our graph of this parabola looking like this. And then we want to plot the line. So the line, we can start with the y-intercept at 3, and we see the slope is 1. So we're going to rise 1, run 1, rise 1, run 1, rise 1, run 1, or we'll rise -1, run -1, rise -1, run -1, because -1 over -1 is still 1. So when we plot this, we have a point here at -1 and then +2. And we have a point right here at 2, 5. So those are our solutions to this system of equations. All right, let's take a look at this one. Now this one we're using some fractions, so it's going to be a little rougher, but we'll do y equals, and let's rewrite this in standard form, -0.5 x squared, and then +5. So I've just taken this right here and put it behind there, so I'm in standard form. And then the next one's already in standard form, so we have y equals -0.5x + 2. All right, so let's take a look. We have start at 5 for this y-intercept here. We see we have a negative, so we know the parabola is opening downward. It's a fraction that's in between 0 and 1, so we know it's going to be moving out more wide than narrow. That's a compression with the y-axis when it's a fraction. So let's look at what this one is. Let's do a quick chart since this one's a little harder for calculating. So what I would do is I would go with factors x, factors of 2. So let's start with, well, we had 0, 5. So that's an easy one. So now let's do 2. 2 squared is 4. Half of 4 is 2, and there's a negative, so that's -2. -2 plus 5 is 3. And now let's do 4. So 4 squared is 16. Half 16 is 8, it's -8. So that's -3. All right, and let's try some negative numbers here. So let's try -2. -2 squared is going to give us the same as 2. So -2 is going to give us 3, because -2 times -2 is 4. Half of 4 is 2, and it's a negative, so that's a 3. So we'll see that the same thing happens with 4. So that gives us a bit of some points to plot. So at 2, we are at 3. And we know that this has a axis of symmetry right here because it's basically, there's no horizontal shift with this. So 1, 2, 1, 2. Then we have And we can also see that's 2, -3. So that's what I've just plotted here. Then we have 4, and 4 is all the way down to -3. So 1, 2, 3, 4, 1, 2, 3, 4. So now let's plot those. Okay, so we have the parabola. Fortunately, the line is much easier to graph. So we start with 2 for our y-intercept. And the slope, since it's -0.5, we can write that -1/2. So that's a negative rise of 1, +2, or a positive rise of 1, run a -2. So negative rise of 1, run 2. So when we graph this, the line does decrease as x increases. The y decreases, so that's a negative slope. And this is our line. So we see we have 2 intersections. We have a definite point here at -2, and then that's at 3. Okay, so -1/2 of -2 is +1. 1 + 2 is 3. So that makes sense. We also have an intersection here that seems to be between points. So we would approximate this solution. It's about 3, and it's a little over 0. So let's say 3.5. The half is the y. So that's what I would approximate that to. All right, so that's the solution for these. If sometimes though, when they do ask you to approximate it to the nearest integer, then I would go a step farther and say that that is 3, 0, because it is closer to the 0 than the 1. All right, let's take a look at this one. We're going to use elimination to solve each system of equations. So elimination means we are eliminating one of the values of this. So what we're going to do is we're going to subtract one equation from the other. So if I have y equals -x plus 4, and I have y equals -x² minus 2, I'm going to take this whole equation and subtract it from the top. So y minus y is 0. And then I have -x minus a -x², which would be -x plus x². And then a 4 minus a -4. Maybe I should write that one out. So that might be a little crazy for you to follow. So what we're doing is we're subtracting, but this bottom one is -x². So then we have plus 4 and then minus -2. So let's put that all together. We have 0 equals, and we'll put it in standard form. 2 negatives next to each other like this make a positive. So we have x² minus x, and then we have 4, and then 2 negatives again make a positive, so that's plus 6. So if we did a quick factorizing, we see that it's 1 times 6 is 6, and we have -1. So that means I have 2 negatives making a positive. Ooh, that's a tough one. No, yeah, because I have a positive here and a negative here. So we might actually have to do the quadratic formula. So let's try that because that works for everything. So we have A equals 1, B equals -1, and C equals 6. All right, so I have -1 plus or minus the square root of -1 squared minus 4 times 1 times 6 all over 2 times 1. Okay, so this gives me x equals, I have 1 plus or minus, and I have inside the square root, I have 1 minus 24 over 2. So I see I don't have a real solution. Okay, so this means there's no real solution. So we have no solution. So basically this parabola, it's down at -2. It never hits that. All right, so now we're going to look at, oh, I see, there was a negative. Oh, that makes a lot more sense. It's like, wait, looking at this, you'd see that if this opens up and it drops down to -2, it has to hit that because that's starting at 4. So the problem was that I dropped that negative here. So that's a -1, and that's a -1, and that is going to give us a positive here and a negative right there. Okay, so now that we found the error where this is a positive x squared, that makes so much more sense. So that's one thing, you always have to do sanity checks, especially when you get no solution. That's kind of fishy. All right, so when we look at this with the positive, that gives us the square root of +25. So let's move over here so we have a little more room, and let me grab a different pencil. So we have x equals, so we have 1 plus or minus the square root of 1 plus 24 is 25. The square root of 25 is 5. And that's over -2. So that gives us x equals 1 minus 5 over -2, which is, that's -4 over -2, so that's 2, or x equals, and then that's going to be 1 plus 5, which is 6, divided by -2 is -3. So once we find that, we can just plug it into either one of these equations, or both if we feel like we want to check it. So if we put y equals -2 plus 4, that gives us y equals 2 for this one. Let's double check it. 2 squared is 4, minus 2 is also 2. All right, let's try -3. So y equals -3, which is +3. So 3 plus 4 is y equals 7. Then we have -3 squared is 9, minus 2 is also 7. So then that means that our solutions actually are 2, 2, and -3, 7. So they should work for both equations. So that's a wonderful way to check. All right, let's try this one. Hopefully we won't run into any more no solution issues, which are not true. So we're just going to subtract this from the top. So we have y minus y is 0. Then we have -x squared plus 4x. Then I've got the negative, that's 4x, negative here, -x. And then I have 2 here, and then minus 2. So I'm trying to keep the like terms together. So since this isn't ordered well, I'm just keeping the like terms together. So I have negative x squared plus 4x minus the negative x plus 2, and then minus 2. So let's figure out what we've got now. So we have negative x squared. This becomes a positive, so this is plus 5x, and then 2 minus 2 is 0. So this one's an easy factor. We just pull out x, and then we have negative x plus 5. So we see x equals 0 as a solution, and also 5. X equals 5 is a solution because negative 5 plus 5 is 0, using the 0 property, 0 product property. All right, so let's put x as 0 into one of these and make it easy on ourselves. This one's the easier one. So y equals 2 minus 0 gives us 2. So for this one, we have 0, 2. So I'm putting for x, that's my x value. Let's double check it. When x is 0, y is 2 here as well. So that one checks. The next one we're going to put in is x is 5. So we have 2 minus 5 equals negative 3. So we have 5, negative 3. So let's check that. Negative 5 squared, so negative 25, plus 4 times 5 is 20, so that's negative 5, plus 2 is negative 3. So that checks as well. So we have our 2 solutions right here and right here, just like those 2 solutions. All right, our last example then. Will be this. So instead of using elimination, we're going to use substitution. So since they both equal y, we can say negative x squared minus 2x plus 9 equals 3x plus 20. So now we're going to subtract 3x and subtract 20 from both of this. From this side and the other side to move it all over here. So we're using additive inverses. So this gives us negative x squared. So negative 2 minus 3 is negative 5x. 9 plus negative 20 gives us negative 11 equals 0. All right, so we can multiply by negative 1 to get rid of that negative. And so that gives us x squared plus 5x plus 11 equals 0. Okay. So that's just one way to make it easier on yourself. If you have everything negative, everything's got a common factor of negative 1, multiply both sides and it's gone. Okay, so we have A, B, C. So we have x equals negative b, which is negative 5, plus or minus the square root. And we have 5 squared minus 4 times 1 times 11, all over 2 times 1. All right, so this is going to give us x equals negative 5 plus or minus. We have 25 minus 44. And then we have 2 here. So we see, oh dear, we have another issue with no solution. So we better check this, make sure these two do not ever meet. So that's negative 19. So that's no real solution. So let's double check it. We can do this with a quick graph. So if we had, we'll do a sketch graph. So we start with 9 on this, and it's going to open downward. So if this is 1, negative 1 minus 2 gives us down to 6. So that'd be 6 here, and negative 1 is different. So negative 1 here is 1, and that makes that a positive 2, which gives you to 11. So that's 10. So it goes a little higher. All right, so we see we have something going on like that. And then plus 20 is way up there. So, and plus 20, we have it. It's possible, it just never meets. Okay, so let's see if we have, let's try to find the vertex. So we can find the vertex of this, if you remember, as x equals negative b, so negative negative 2 over 2 times a, which is negative 1. So negative b over 2a, negative negative b, a negative b over 2a. So we have negative, b is already negative, and 2, and a is negative. There we go, so many negatives. So this becomes positive 2 over negative 2 gives us negative 1. So our axis of symmetry is right here. So that means at negative 2, we should be back here. So negative 2 gives us 4 with a negative, so negative 4. Negative 2 here, negative 2 times negative 2 is 4, so that zeroes out, and we indeed are down like this. Okay, so that's our parabola. This one, it's way up at 20, which is way up high. And then it's got a 3x graph. So by the time it's down here, let's see where this crosses. This probably crosses, that's 1, this probably crosses at 2. So 2 squared negative 4, and then negative 8. So 2's here. So it crosses are between 2 and 3. So if we put 3 in here and it's not even close to this, we know that it never hits. So actually negative 3. Well, let's see, actually negative 4 would be down here. Just so negative 12 plus 20 is 8. So that's way up here. Yeah, so this line is shooting up like this. So there is no solution. So we have just double checked. So there are no math errors in this one. We definitely don't have any intersection between these lines. All right, that's it. Have a wonderful day.